Hello everyone, I am Aditi Arora from ABES Engineering College, Ghaziabad. In this video lecture, we will be starting with Unit 2 of Operating System BCS-401, that is Process Synchronization. So the outline for today's lecture is what is process synchronization? First of all, we will understand the concept of process synchronization. Then, what is the need of process synchronization? Then we will understand about a very classical problem of synchronization, that is producer-consumer problem. And then lastly, we will discuss a very important concept, that is race condition. So talking about process synchronization, it is basically introduced to deal with the problems that comes during the execution of multiple processes. Now, we all know that nowadays we use multi-programmed operating systems and time-sharing operating systems, where multiple processes share the CPU and execute simultaneously. So based on synchronization, first of all, we can categorize the processes into two types. First is independent process and second one is cooperative processes. Now, what is independent processes? Those processes which are completely independent of each other, means the execution of one process is altogether independent of the execution of another process. They do not interfere with each other's execution, or they do not depend on each other's execution. Next is cooperative processes. So here, the execution of one process definitely affects the execution of another process, right? So basically, cooperative processes are those processes that share a logical address space. Now, what do you mean by logical address space? Means they can share both the code or the data. They can work together on the same code on the same data, or also they can also do their sharing through files and messages. So now with independent processes, there is no problem to execute because their execution is independent of each other. But the problem arises when we talk about the cooperative processes. Now, what is the problem here? So the problem is that whenever the two cooperative processes concurrently access a shared data, then their execution may result in a problem called as data inconsistency. So जब भी हमारे पास दो या दो से ज्यादा प्रोसेसेस किसी शेयर्ड डेटा को यूज करेंगे, शेयर डेटा को या शेयर्ड कोड को जब भी यूज करेंगे, देन इट मे बी पॉसिबल कि दोनों ही जो है कंकरेंटली जब शेयर डेटा को यूज करेंगे, देन इट मे लीड टू डेटा इनकंसिस्टेंसी। मींस फाइनली हम ये डिसाइड नहीं कर पाएंगे कि विच वैल्यू इज करेक्ट एंड विच वैल्यू इज इनकरेक्ट। सो So the orderly execution of the cooperating processes that share a logical address space is quite important so that the data consistency can be maintained. Now, how we can achieve this? So we can achieve this by various synchronization techniques that we will study in the subsequent lectures, such as semaphores, monitors, and critical sections. We will discuss about these in details in our subsequent lectures. Now let us understand that why do we need process synchronization with the help of two very strong examples. So the first example is this. Let's say we have two processes, process P1 and process P2, and they both are sharing a common shared variable stored in the memory named as shared, whose initial value is 5. Now let us say that process P1 starts execution first. So what will happen? Firstly, the value of shared variable 5 will be saved to the local variable x, which is of integer value. And in the second instruction, the value of x is getting incremented by 1. So here the value will become 1. Now the process P1 executes the sleep instruction. Sleep instruction means the process P1 is going to halt its execution for 1 second. And if the process P1 halts its execution, that means now the context switching will occur and the CPU will switch to the other process that is present in the ready queue. Now, which process is present in ready queue? Process P2 is ready to execute on CPU. So the CPU will now start executing process P2, right? Here again the shared value, variable value, that is 5, will be stored in the local variable y, and in the next instruction y is getting decremented by 1, so the value here will be 1. Now again process P2 is going into the sleep state. Now means once again context switching will occur here and the CPU will again resume the execution of process P1 where it was stopped earlier. So process P1 will start its execution from the fourth instruction, and here the value of x, what is the value of x here? 6. 6 will be stored in the final value, that is shared variable. So now the value of the initial value of, the final value of shared variable will be 6. Now, after executing the last instruction, the process P1 is successfully terminated and it will release the CPU. Again, now we do not want to get the CPU idle. So again, the CPU will resume its execution from process P2 and it will start from this instruction. Now, what was the value of y? Value of y was 4. So it will be stored in the shared variable. Now, the final value of shared variable is 4. Now, you should develop an understanding from this scenario that ideally what should be the value of shared variable after the completion of both the processes, process P1 and process P2. Ideally, the value should be 5 because one process is incrementing the value by 1 and the other process is decrementing the value by 1. So the value should be 5 only. But here, if we execute process P1 and then P2, the final value is 6. And whereas if we execute process P2 first and P1 later on, then the value will be 4. But both the values are wrong. So here, both these values are actually racing with each other, that what value will be the final outcome of the execution of these two processes. So this is one example where we need to understand that these processes should be synchronized in order to have the consistent value of the final variable in the database. So here, these processes are not yet synchronized with each other. Their execution, their order of execution is currently not synchronized. Hence, we are getting different results based on the order of execution, right? This is the one order and this is second order. Now again, we will understand the concept that why do we need process synchronization with one more very good example, that is producer-consumer problem. It is basically a classical problem of synchronization. I hope you now have understand the meaning of synchronization, process synchronization. So here, basically, we have a producer process and we have a consumer process. The producer process produces the information, whereas the consumer process consumes the information, right? Or information, or we can say item, right? And we have a buffer. Okay, and this buffer is stored in the main memory that is shared by both the producer process and the consumer process, right? So a producer process produces the information, whereas the consumer process consumes the information. Okay, so we can understand this by an example. Like we have the web server which produces the web pages and that are being consumed by the clients using the various web browsers. So this producer and consumer are basically sharing this memory space, and in this memory space we have a buffer of items that can be filled by producer and items can be consumed by the consumer. Now, this buffer will reside in the region of a memory and it will be shared by producer and consumer process. Now, this is very important point to consider here in this problem, that the producer can produce one item while the consumer is consuming the item, right? Now, the main point is here that the producer and the consumer should be synchronized with each other. Like the consumer does not try to consume an item that has not been yet produced. अगर प्रोड्यूसर कोई आइटम प्रोड्यूस करेगा तभी उसके बाद कंज्यूमर जो है उसे कंज्यूम कर सकता है. कंज्यूमर ऐसा कुछ भी कंज्यूम नहीं कर सकता है जो कि फिलहाल प्रोड्यूसर के द्वारा प्रोड्यूस ही नहीं किया गया है. Now, talking about the buffer, basically we have two kinds of buffer, that is bounded and unbounded buffer. So what do you mean by unbounded buffer? Unbounded buffer means there is no practical limit on the size of the buffer, right? The consumer may have to wait for the new items, but the producer can always produce the new items. Producer can always produce, can always fill this buffer with new items, but consumer can only consume when there is some item in this buffer. Whereas bounded buffer means a fixed size of buffer, fixed size buffer. In this case, the consumer must wait if the buffer is empty. Obviously, when the buffer is empty, there is nothing to consume by the consumer, right? And the producer must wait if the buffer is full. So if the buffer is already full, the producer is unable to fill this buffer with some new item because the buffer size is limited. So in order to understand this problem, basically we consider the bounded buffer. Right. So we will understand this problem with the help of an example. Let's say we have taken a variable named as counter whose initial value is 10. Now, the producer process will execute the instruction counter plus plus every time it produces one item, whereas the consumer process will execute counter minus minus whenever it consumes one item from the bounded buffer. Now, look at this example table. Let us understand that first of all, the producer starts its execution and it places the current value of counter, that is 10, into its register, that is register 1. And in the second step, again the producer takes the hold of CPU and executes the instruction counter plus plus. Now, what happens when counter plus plus will be executed? Actually, the register value will be incremented by 1. What was the initial register value? That is 10. So 10 plus 1, 11. So now the register 1 value will be 11. Now, in the third time, that is, sorry, at the time instance T2, consumer takes the hold of CPU and it executes the instructions. So basically, for consumer, the counter value is 10 and it places this counter value, it saves its counter value into register 2, and in the subsequent instruction at time T3, it executes the statement counter minus minus, resulting in the value of register 2 to be decremented by 1 and the value will be 10 minus 1, that is 9. Now, at time T4, let us say that producer takes the hold and it executes the instruction. Now, what does it will do? It will place the register 1 value to again the counter variable which is placed in the memory. right, which is a shared variable, and both the processes want to update this counter value concurrently. That means at the same time they want to update this variable. So say for example, producer firstly gets the hold of this counter variable and it executes its instructions. And what will be the final value of counter? 11. This final value is generated by producer. And now if at point T5, consumer gets the hold, then the register 2 value is 9 and it will be saved to the counter variable and the final value will be 9, right? So again, in this example, ideally, what should be the correct value? What should be the correct output? Ideally, the value should be 10 because producer process is incrementing the value, counter value by 1 and consumer process is decrementing the counter value by 1. But depending upon here, the order of execution, if we say that the producer comes first and then consumer, so the value of the counter variable is 11. But if the consumer first gets the hold of CPU, it executes first and then later on the producer, the value will be 9. But both these values are incorrect. So we are arriving at this incorrect state because we allowed both the consumer process and the producer process to manipulate the counter variable concurrently. So we can understand clearly from here that it is required that the resulting changes should not interfere with each other. Hence, we need process synchronization. These processes were not actually synchronized with each other. Their order of execution was not synchronized. अगर प्रोड्यूसर प्रोसेस पहले पूरा एग्जीक्यूट हुआ होता एंड देन कंज्यूमर प्रोसेस पूरा एग्जीक्यूट हुआ होता है, देन देयर विल बी सिंक्रोनाइजेशन. ठीक है, आइडियली द वैल्यू जो फाइनल वैल्यू आती दैट विल बी 10. बट हियर इन एक्चुअल सिचुएशन प्रोड्यूसर एंड कंज्यूमर प्रोसेस both came to access the value of the counter variable concurrently, and these two processes were not synchronized, resulting in the data inconsistency situation. So after understanding the previous two examples, we now come here with a very important definition, that is race condition, which can be defined as a situation where several processes access and manipulate the same data concurrently, and then the outcome of the execution totally depends on the particular order in which the access take place. This phenomena, this situation is called as race condition. So from today's understanding of the lecture, we have the concluding remarks that the main objective of process synchronization is to achieve data consistency. So these are the references from where we have prepared the content for today's video lecture. Thank you.